Hello everyone. In this video, I'm going to do a quick explanation about logarithmic and exponential form, and then how to go back and forth between the two. So I'll start with logarithmic log form. Recall that it is in equation form. I'll use y equals log base b of x, where my base b has to be greater than 0 and cannot be equal to 1, and my domain of log the x also must be greater than 0. So logarithmic, going from log form to exponential form requires no mathematical work, all we're just moving things around in essence. We can use it to solve equations, and quite often it's one of the simplest ways of solving an exponential equation, or conversely, a log equation. But when it comes to solving, as I said, it's just going to be moving numbers around. So let me put the comparable form of the exponential. Based on this, the equivalent exponential would be b base b to the y power equals x. So the b here is the same as it is in log. It's the same b, the same y, and the same x. So again, what I've done is I've just moved things around. In other words, if this log equation exists, therefore this exponential equation must exist also. You can't have one without the other. For example, I'll say y equals log base 3 of x, and I say put that in exponential form. Simplest way for exponential form is to say, let's start with the base, that's going to be 3. And then whatever the log is equal to becomes my power, and I'm equal to that x, or what I'm taking the log of. So let me do another one. For example, I'll say y equals log base, let's say 4 of 6, for example. I said, well, in exponential form, that's going to be my base 4 to the power of y equals 6. So, and if you know anything about the history of logs, they were created by John Napier as a quick way at the time, and they're also used for astronomical calculations. But another reason they were used is to help mathematicians and, as I said, some astronomers do large calculations, because it was a way of converting multiplication to addition and division to subtraction, the way of reworking things in a time when calculators didn't exist. And as you can see here, the solution to my equation on the right, 4 to the power of y equals 6, in other words, 4 to what power would give me 6? The solution is log base 4 of 6. Now, there is a specific value for that, which was calculated. So there are terms of log base 4 of 6 equals this, log base 4 of 7 equals this, and so on. That's one of the uses, I guess, of both of these forms. So again, let me do another example. I'm going to say 6 equals log base 2 of x. So in exponential form, I'd say 2 my base to the power of 6 equals x. And likewise, we can use going between exponential and log form to solve equations. So if my equation was on the right here, or on the left, solve the equation 6 equals log base 2 of x, for what value of x is true, you'd say, you change form, you'd say, well, 2 to the 6th power, or 64 would be your solution. And this works the same with log of any base as well as natural log. So if I have, let's say, 11 equals natural log of, I'll say x again. Notice when I don't put a base down here for my natural log, we assume it to be e. So we'd say this is equivalent to saying e to the power 11 equals this x, whatever that is. And the same can be said for, excuse me, going the other way. If I instead say, pardon me, I'll have, let's say 11 to the power 3 equals some value x. To put in log form, I like to start with log. My base is 11, so it's still log base 11. Now, x, as you can see, will be in the log. Whatever the exponent is becomes the solution to this, so equals 3. So log base 11 of x equals 3. Let's look at another one. I'll do it over here, and then I'll do a couple more examples. So if I have, let's say, I would do 2 raised to the power y equals 14. Is they put this in logarithmic form or log form. Again, I like to start with log, so log base 2. Whatever the power is what log is equal to, so I'll say equals y, and then the 14 is inside the log. And this also works with multiple expressions too. So if I say, let's say 3 plus x equals log, base 7 of 11. In exponential form, we'd say base 7 to the power 3 plus x equals 11, just like so. If I said 4 equals log, and I would say x plus 4. Let me say, I use 4 a lot. I use 4 too much. Let's see x plus 8. There we go. So again, notice I didn't give a base, so we assume it to be 10. In exponential form, my base 10 raised to the 4th power equals x plus 8. And again, because that's in parentheses, that's how I know to bring the entire x plus 8 with me. I would not, if I didn't have the parentheses there, I wouldn't be able to do it the same way. It would not be equal to x plus 8. So the parentheses are important. And conversely, going the other way, if I have, let's say, color here. Let's say if I had 6 raised to the, I'll say 2x power equals 11 in exponential form. Again, I like to do log first, log base 6. The exponent is what the log is equal to, and then of 11. And similar to with other problems, you can solve this one. If the question was to solve, you would solve by dividing by 2, and that would be your answer. So this is my brief explanation of going between exponential and log form. Hopefully this makes sense, and have a good day.